Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hamzi Zahidi bin Muhammad Noh, 25B 1626, and I will be presenting our topic, which is working with external data sources, file handling techniques in Python for reading and writing data. Here is the content list for my slides. So moving on to the introduction, what is external data? External data refers to data stored outside the program, usually in files. Since different systems store data differently, file handling is important to manage and standardize it. File handling also involves creating, reading, writing, and closing files. It allows data to be stored permanently instead of being lost after a program ends. It also plays an important role in many real-life applications, such as financial systems. The difference between temporary and stored data is also important to understand. Temporary data is lost when a program or device is turned off, while stored data remains available even after the system is shut down. Next, understanding files in Python. In Python, files are used to store data permanently so that it can be accessed even after a program has finished running. There are different types of files, with the most common being text files and CSV files. Files are stored in a structured way on a computer, where each file has a name, location, and format. Python also provides different modes to work with files, such as read, write, and append. Syntax for file handling. In Python, file handling is done using built-in functions that allow us to open, read, write, and close files. The most important function is the open function, which is used to access a file by specifying its name and mode. Once a file is opened, we can read its content using methods such as reading the entire file, reading one line, or reading multiple lines. Writing to files is done using functions that allow us to store new data. After performing file operations, it is important to close the file to ensure that resources are properly managed. Reading and writing data. Reading allows a program to retrieve stored information such as student records or system logs for processing. Writing allows programs to store results for future use. For example, a program can save calculated grades into a file so they can be accessed later. Appending is used to add new data without removing its existing content. And lastly, file paths must be handled correctly, as incorrect paths can cause errors. Managing data from external sources. After reading data from files, the next step is managing and processing data. Raw data is often unorganized, so it needs to be cleaned and structured before use. Another important step is converting data into usable format. Since file data is usually read as text, it may need to be converted into numbers or separated into parts for processing. Basic data handling techniques are then applied, such as storing in lists and performing operations like sorting or calculating averages. This will allow the program to generate meaningful results. In conclusion, managing data from external sources ensures that raw data is transformed into useful information, which is essential for real-world applications. Next, I will pass to my groupmate, Haji Arief.
Now it's my turn. My index is 25B 1611. I am Awangku Haji Muhammad Arief Aieman bin Pengiran Haji Petra, and I will explaining about basic data persistence using text files, our flowcharts, how to handle multiple files, and conclusions for this topic. In here, basic data persistence using text files. Basic data persistence refers to the ability to store data permanently so it can be used again even after a program has stopped running. In Python, text files are one of the simplest methods to achieve this. They allow programs to store user inputs, results, and logs in a readable format. Unlike variables, which only exist during runtime, data stored in text files remains available for future use. Now I'm showing you type of code and results. Here I provide 4 types of codes with says write data to a file, reading data from a file, appending data, and reading line by line. First, I write data to a file. Writing data to a file allows program to store information permanently. Using write mode, a file can be created or overwritten with new content. This is useful for saving user data or program result. After that, I can read data from a file. Reading data allows programs to retrieve previously stored information. This enables reuse of data for processing, display, or further operations. Now it's time for appending data. Here I show you a code for appending data. Appending data allows new information to be added to an existing files without removing previous content. This is especially useful for maintaining logs or records over time. Unlike writing mode, append ensures that early data remains unchanged while new data is continuously added. And finally, reading line by line. Reading a file line by line allows data to be processed more efficiently, especially when dealing with larger files. Instead of loading all content at once, the program reads each line individually, providing better control and reducing memory usage. And here, I provide you with flowcharts in file management system. Over here, the top is start, so the program will begin. Second, with operating file, open file, the system attempts to open file. So the question is, the choice there. Does the file exist? If yes, then the output will perform either read, write, or append, and then it will process the data line by line or the whole content. But what if the file doesn't exist? So we will create new file, and then we can go to process data line by line again or whole content. The question again, is there any multiple files? If no, we will go straight to the end and the process will finish. If yes, if there's any multiple files, and then open the next files, and then again the process finish. In this section, show how file handling move from basic usage to more practical real-world scenarios. Data is rarely stored in a single file, while programs often need to handle multiple files simultaneously to organize, process, and combine information efficiently. There are 3 common use cases that I provide. One of the 3 is combining data from several text files into one file, processing logs stored in separate files, separating input and output data for better organization. So we'll go through file management techniques. Why? Because proper file management is important when working with multiple files to avoid confusion or data loss. So here I provide 4 key techniques. One of the 4 is using clear and consistent file naming conventions. Second, closing files properly after use. Third, using loops to process multiple files automatically. And lastly, storing process results in separate output files. Working with multiple files improve efficiency and scalability in programs. By organizing and managing files properly, programs can handle larger and more complex data effectively. So in conclusions, file handling in Python allows data to be stored, accessed, and managed efficiently using external files. Through this assignment, key operations such as reading, writing, and appending data were explored along with techniques for processing data line by line. More advanced concepts like handling multiple files and managing structured data were also introduced, showing how files handling is applied in real-world situations. Overall, file handling improved data organization, scalability, and efficiency, and served as a strong foundation for developing practical and data-driven applications.